In number 25, we want to determine the left and right hand behavior of our graph. So we know that we have a positive leading coefficient and an odd degree. So it will start down and finish up, which means the left will be down and the right will be up, which is choice A. Number 26 is the same question, and we have a negative leading coefficient with an even degree. So we know that both ends will be down. So that would be choice D. For number 27, to find the zeros, I'm first going to factor out an x squared. So I have x squared, and I get x to the fourth minus 1. And then I see that that's a difference of squares, and I can factor more. So I get x squared minus 1 and x squared plus 1. And then I can factor x squared minus 1 even more to x plus 1, x minus 1. But I can't factor x squared plus 1 anymore. So I'm going to leave it like that. So that means that I'll have zeros at 0, -1, and 1. The zeros from x squared plus 1 will be imaginary, so I don't need to include those. So D will be my answer. In number 28, we want to find a polynomial with the given zeros. So I'm first going to write those zeros in their factors. So if I have a 0 at 0, it's just an x. If I have a 0 at -1, I have an x plus 1. And if I have a 0 at 2, I have an x minus 2. And since these are in factored form, I know that my answer is B. In number 29, we want to match the graph with its equation. So if we take a look at the graph, we notice that it has a negative end behavior because it starts up and finishes down. So it must be a negative leading coefficient with an odd degree. So if we take a look, that would definitely eliminate C and B and A. So it must be choice D, and choice D is written a little bit funny. It would probably be easier to rewrite it as -2x cubed plus 3x squared. So that was a little bit of a tricky problem. In number 30, we want to divide using long division. So I'm going to put 3x plus 2 out in front, and 9x cubed minus 6x squared minus 8x minus 3 on the inside. So in order to get a 9x cubed, we have to multiply by 3x squared. So that would give us 9x cubed plus 6x squared. And we need to remember to change both the signs. So we have a negative 12x squared minus 8x. And that means we would need to multiply 3x by a negative 4x to get a negative 12x squared. So we have a negative 12x squared, and that would be minus 8x. And we change in both the pluses. So that would just end up with a 0. And if we drop down the -3, -3 is a bit too small, so that is our remainder. So we put the -3 over what we were originally dividing by, which was 3x plus 2. So that would be answer C. In 31, we want to divide 5x to the fourth minus 2x squared plus 1 by x plus 1. What we need to remember on this one is that there are some terms missing, so we need to fill in some zeros. So we have 5x to the fourth plus 0x cubed minus 2x squared plus 0x plus 1. So now we need to check what do we need to multiply x by to get 5x to the fourth, which will be 5x cubed. And then we need to multiply. So we'll get 5x to the fourth plus 5x cubed. And then change the signs. So we have negative 5x cubed minus 2x squared, and that would be a negative 5x squared. And that would be negative 5x cubed minus 5x squared. I'm going to change the signs. So that gives us a 3x squared plus 0x. That would be a 3x. And that will be 3x squared plus 3x. And change the signs. So negative 3x plus 1. So we have a minus 3. And we will get negative 2 as our remainder. Oops, I forgot to change the sign. So that'll actually be plus 4. So that would be choice A. In number 32, we need to use synthetic division to factor the polynomial. So we know that 1/2 is a 0. So we're going to use that on the outside. So if I drop down the 2, I'm going to have a 1 and a negative 6, a negative 3, a 4, and a 2. So now I take my remaining 3 and factor. And I can actually divide them all by 2 to make it a little bit easier. So it factors into x minus 2. Oops. That'll be x minus 2, x minus 1. So I have zeros. Oh, we just need to factor it. So the complete factorization would be x minus 1/2, x minus 2, and x minus 1, which would be choice C. And the 2 out in front comes from factoring the 2 out in the beginning, right here. In number 33, we want to divide the polynomial by k equals 2, and then write the answer in this special form. F of x equals x minus k times q of x, which is the quotient, plus r, which is the remainder. So I'm going to do synthetic division with 2. And I'm missing an x squared term, so I need to fill in a 0. So I have 3x cubed minus x squared minus 2x minus 3. And my remainder is negative 7. So writing it in the special form, we know that we're going to have x minus k, which is x minus 2, times our quotient, and then our remainder is in the back. So our answer would be choice B. In number 34, we want to use synthetic division to find f of 3. So instead of actually taking 3 and plugging it in, you can use synthetic division to find the answer. So we'll put a 3 on the outside, and we have a 1, 0, because there's no x cubed, 2, negative 1, and negative 1. And we'll do synthetic. And 3 times 32 would be 96. So the last number is always your solution. So 95 is our answer for f of 3. We don't want to use a because we're not finding the quotient. We're finding what you would get if you actually took 3 and plug it in. For number 35, we want to find the vertical asymptotes. And to do that, we set the bottom equal to 0. So we know that we'll have vertical asymptotes at plus or minus 3. So choice D would be the answer. For number 36, we want to find the horizontal asymptotes. And we see that the degrees are the same. So we divide by our leading coefficients, which is just 1. And since it's a horizontal asymptote, it's going to be y equals 1. X equals is for vertical asymptotes. In number 37, we want to find the domain. So in order to do that, we're going to factor the bottom. And when we do that, we see that we cannot plug in a 2 or a 1. So our answer would be C. All real numbers except 1 or 2. Number 38, we want to find the x-intercepts, and in order to do that, we set the top equal to 0. So we'll get that x equals 1/2, and that will be our only x-intercept. So our answer is B. Number 39, we have an absolute value function, and for these we need to remember that there are 2 horizontal asymptotes. Since the degrees are essentially the same, we find the horizontal asymptotes the same way. We take the leading coefficient and divide it by the leading coefficient. So my first horizontal asymptote will be 1, and then my other one will be -1. So the choice is A. In number 40, we want to find all the intercepts. So in order to find all the intercepts, we need to set the top equal to 0 to find the x-intercepts. So x squared minus 16 equals 0. So that will be x equals plus or minus 4. So we know we have x-intercepts at 4, 0, and at -4, 0. To find the y-intercept, we take 0 and we plug it in. So if we take 0 and plug it in, we get 16 over 9. So that'll be 0, 16 over 9, which would be choice D. In number 41, we want to match the graph with its equation. So if we take a look at the graph, we know that we have a vertical asymptote at x equals 1, because that makes the bottom go to 0. So that would eliminate choices 1 and 2. And we can tell by the top that we are going to have an x-intercept at -3. Because if we set the top equal to 0, we would get that x-intercept at -3. So it looks like that choice 3 would be a solution. Another thing we could check is our horizontal asymptote. And since the degrees are the same, we know that our horizontal asymptote would be y equals 1. But that doesn't narrow it down too much because 3 and 4 look like they both have a horizontal asymptote at 1. Another thing we could check is the y-intercept. If we plugged in 0, we would get a y-intercept at 0, -3, and that looks like it matches up with graph 3 as well.